Hello students and friends, welcome to my channel CGAT Maths. Myself Dr. Suresh Brother. In this video, we are going to find the Fourier series function x square, that is f of x is equal to x square in the interval minus pi to pi, and also deduce these three series after getting a Fourier series. That is first one, pi square by 12 is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus so on. Second one, pi square by 6 is equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus so on. And third one is pi square by 8 is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus so on. So this is very easy example. So now first let us write the Fourier series, student. Okay, what is the Fourier series? Fourier series in this interval, that is Fourier series for the function f of x is, okay, that is f of x is equal to a naught by 2 plus summation n runs from 1 to infinity an into cos nx plus summation n runs from 1 to infinity bn into sin nx. So this is the required Fourier series. Okay. So now, and we also have Fourier coefficients, students. That is a naught is equal to for the general interval, that is c to c plus 2 pi. Okay, a naught is equal to 1 by pi. Integral runs from c to c plus 2 pi f of x into dx, and an is equal to 1 by pi. Integral runs from c to c plus 2 pi f of x into cos nx into dx, and bn is equal to 1 by pi. Integral runs from c to c plus 2 pi f of x into sin nx into dx. Now fine. Now let us concentrate here. Okay. So now as usual, for the given function, without using the definition or concept of a odd and even nature, we need to find out a naught, an, and bn. Okay. If we use the concept of even and odd function, because the given function f of x is equal to x square is a even function. How do we verify for even function? Actually, in the interval that is minus pi to pi. So to verify for even function, if x is replaced by minus x, if you get f of x, we say that it is even function. Further, if x is replaced by minus x, you get minus of f of x, we say that it is odd function. Now here look at, replace x by minus x is equal to, this is minus x whole square, minus x whole square is x square, is same as f of x. So f of minus x is equal to f of x, means this is even function. So if f of x is even function, then we required to find only A naught value and AN value, then BN become 0. Okay. So why BN becomes 0? Okay, I am going to explain why it is BN equal to 0. For example, look at student. Here f of x is a even function. If f of x is a even function, okay, f of x is even function, and by using the standard integral, we know that that is minus a to a f of x into dx. So its value is 2 times of 0 to a f of x into dx, and it is 0. This is when which is even, when which is odd. Odd means this should be satisfied. Look at, if f of x is even, okay, we are going to write the value of a naught as 1 minute. Fine. If f of x is even, then a naught value becomes 1 by pi. Okay, f of x is even means we are going to write it as a, this is minus pi to pi. Minus pi to pi can be written as 0 to pi only, student. This is 2 times of 0 to pi f of x into dx. Okay. Then what is the value of an? An is equal to again 1 by pi. Since look at, since f of x is even function, okay, even function, again cos nx is also even function. The product of two even function is again even function. Therefore, it will become that is again 2 times of 2 times of 2 times of 0 to pi f of x into cos nx into dx. So now look at the value of bn, 1 by pi times of, here f of x is a even function, sin nx is odd function. The product of odd and even function, the product of odd and even function is odd. Therefore, this value is 0. That is, in general, you can write it as a what? Minus pi to pi. Okay. Minus pi to pi, that is a value is minus pi, a value is pi, minus pi to pi, f of x dx value is 0 when the function is odd. Okay, so this is even, obviously f of x is even, sin nx is odd, product of even and odd is odd, therefore it will become odd, then bn value is 0. So for that purpose, students, whenever the function is even, we are not going to calculate bn value. We just find out only e naught value and an value, student. Okay, so let us find out a naught and an and substitute in the given series. Fine. Now the value of a naught equal to 1 by or 2 by pi. Okay. Integral runs from 0 to pi. Okay. Actually, minus pi to pi is reduced into half. Actually, this is minus pi to pi reduced into half. 2 times half. So minus pi to pi becomes 2 times of 0 to pi, student. Okay, 0 to pi f of x. F of x value is, we know, x square into dx. So just you can write 2 by pi, integration of x square is x cube divided by 3 between the limits 0 to, so which is 2 by pi. Okay. Substitute upper limit, which is pi cube by 3 minus 0 cube by 3. So the value of a naught becomes 2 by pi into pi cube by 3. Pi and pi get cancelled. Cross multiply a naught. A naught by 2 is equal to pi square divided by. So next we are going to find out an value. So to find out an value is again 2 by pi. Okay. Integral runs from 0 to pi. Students, you must remember that if you are not using the concept of odd and even function, you use the value of a naught, an, bn, what the previously expressed. Okay. So this is f of x is x square into cos nx into dx. So this integration is very easy. Just we have done in the previous example. Okay, let's look at carefully. Now this is 2 by pi. We use Bernoulli's rule. First function x square, integration of cos nx is sin nx divided by n, minus differentiation of x square is 2x. Double integration of cos nx is minus cos nx divided by n square plus differentiation of 2x, that is 2. So into again one more integration of minus cos nx by n square is minus sin nx by n cube between the limits 0 to pi. So you can remember the formula, student. Bernoulli's rule. What is Bernoulli's rule or Bernoulli's generalized formula for integration by parts? Integration of product of two function is equal to first function integration of second function minus differentiation of first function double integration of second function plus double differentiation of first function triple integration of second function and so on. So this one we are using. So next differentiation becomes 0. We are stopping here itself. And students, you must remember that the value of sine for the angle 0 is 0. Okay. For pi is 0. Okay. For 2 pi is 0. In generally, sine n pi or 2n pi is 0. Sine pi by 2 is 1. Okay. Sine minus pi by 2 is minus 1. And cos 0 is 1. Cos pi is minus 1. Cos n pi is minus 1 whole raised to n. Cos 2n pi value is again 1. Okay. So now here the first and third term containing sine function by substitution of upper limit pi, sin pi is 0 and lower limit for 0 is also first term becomes 0 and third term becomes 0. So just use only the middle term or second term. Okay, so you can write 2 by pi here 2 by n square. This is minus minus plus 2 by n square is constant. You can write 2 by n square outside. And what is remaining? X cos nx. Okay, between the limits 0 to pi. So this is 4 by n square pi. Substitute upper limit pi cos n pi. Okay. Minus x equal to 0. Just substitute 0. 0 into cos of n into 0. So this is 4 by n square pi into pi. Cos n pi is minus 1 whole raised to n, and 0 into cos 0 is 0, and pi get cancelled. So what is remaining? Remaining is 4 by n square into minus 1 whole raised to n is the value of an students. Now, the required Fourier series becomes, by substitution of a naught and an value, f of x is equal to a naught by 2 value is, which is pi square by 3 plus summation n runs from 1 to infinity. A n value is 4 by n square into minus 1 whole raised to n into cos nx, and you know that bn value is 0 because of even function. So now, after getting this step, what I need to do is I need to expand this series. Okay. So this is f of x is equal to pi square by 3 plus you can take 4 outside, and substitute n is equal to 1, 2, 3, so on. By substitution of n is equal to 1, minus 1 whole raised to 1 is minus 1 by n square, 1 square into cos of n value is 1 is cos x. Next, minus 1 whole raised to 2. Take n is equal to 2, you will get 1 by denominator 2 square into cos of 2x. Next value is minus 1 whole raised to 3 is minus 1 divided by 3 square into cos of 3x, plus minus 1 whole raised to 4 is 1 by 4 square into cos of 4x minus 1. Now, after getting this step, to get a first series, as you know already, what is a first series, student? The first series is here it is. Pi square by 12 is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus 1. Okay, we need to deduce this series. So to reduce that series, get what is the value I am going to substitute, or what is the value we are going to substitute? What is the value of? Fine. So which value we are going to substitute here? Let substitute x equal to 0. So left side becomes f of 0. So this is pi square divided by 3 plus 4 times of it. Cos 0 is 1. Again cos 0 is 1. Cos 3 into 0 is 1. Cos 4 into 0 is 1. So you will get minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square plus 1 by 4 square minus 1. Now, what is the value of f of 0? Students, we know that f of x value is x square. By substitution of x equal to 0, you will get 0 square or 0. So this is 0, okay. And transform pi by 3 to left side, it will become minus pi by 3. Okay. So what is left here? Left is 4. You can take minus common here. So you will get 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus so on. So this minus and minus get cancelled. So you will get finally you will get this is pi square cross multiply 4, pi square by 12 is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus so on. So this is the first result. Okay. Next, to obtain second result, and what I am going to do is just can substitute x equal to pi. So by substitution of x equal to pi, f of pi is equal to, this is pi square by 3 plus 4 times of, look at here, cos pi value is minus 1. This is minus 1 by 1 square into minus 1 plus 1 by 2 square into cos 2 pi. Cos 2 pi is 1, students. Next, minus 1 by 3 square into cos 3 pi is again minus 1 plus 1 by 4 into cos 4 pi is 1. So again f of pi, f of x equal to x square, f of pi becomes pi square. Just substitute, this is pi square. To transform, this is minus pi square by 3 is equal to 4 times of minus minus plus 1 by 1 square, 1 by 2 square, again minus minus plus 1 by 3 square plus 1 by 4 square plus so on. Okay, fine. Further, get carefully. So LCM is here 3, students. 3 pi square minus pi square is equal to 4 times of, this is 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus so on. Cross multiply it. 3 pi square minus pi square is 2 pi square divided by 4 3s are 12 is equal to, this is 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square. This is 2 ones are 2 6. So this is the second series, student. So this is first series, this is second series. So now by adding these two series we get third series, student. By adding these two series we get third series. So just you can add here. So let us add these two. Add, you can call it as Roman number 1, this is Roman number 2. On adding, add left side, which is pi square by 12. Here this is pi square divided by 6. The right side, look at 1 by 1 square plus 1 by 1 square is 2 times of 1 by 1 square. Again 1 by minus 1 by 2 square plus 1 by 2 square becomes 0. Okay. Next, 1 by 3 square plus 1 by 3 square is 2 times of 1 by 3 square. Next, minus 1 by 4 square plus 1 by 4 square is 0. Next term, 2 times of 1 by 5 square plus so. So this is, you can take LCM, which is 12. 12 ones are 6 twos are. So this is 3 pi square divided by, divided by 12 is equal to 2 times of, is 1 by 1 square plus 1 by 3 square plus 1 by 5 square. So finally, this is 3 ones are 3 fours are, can cross multiply 2, will get pi square by 8 is equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square, and so. Thank you so much, students, for watching. Please, we'll see in the next video.